Hello Algebra 2 students. This is the second part of section 12-3 ellipses. Just a quick reminder of what you learn about the basic characteristics of an ellipse. An ellipse in the default position has two fixed points. These two fixed points are called the foci. One focus is F1, the other one is F2. Also, you learn that these two endpoints of the major axis, this horizontal line, this longer axis is called the major axis. These two endpoints of the major axis are called the vertices of the major axis, the vertices of an ellipse. If this distance from the center of the ellipse to this vertex is A, the coordinates of this vertex gonna be A, 0, and in the opposite side this distance gonna be negative A, negative because of the direction, not because of the value of A, because distance is always positive. The center of this vertex gonna be negative A, 0. Similarly, if this distance from 0 to this point is B, the coordinates of these points are 0, B, and we call this point the covertex of this ellipse. In the opposite way, there is another covertex. The coordinates are 0, negative B, and this short axis is called the minor axis. So the longer one is major axis, the shorter one is minor axis, and these 2 points are called the foci. Also, you learn a very important property. If you take any point on the ellipse, the distance, the sum of the distances from this point to the first focus plus the distance from this point to the second focus is always a constant, regardless the position of this point. If you take another point just right here and you draw distance from that point to the first focus and another distance from the same point to the second focus, if you add this distance to this distance, it's the same constant all the time. The situation is quite different if this ellipse is flipped, so the major axis is vertical and the minor axis is horizontal. The only difference between this position and that position, the two vertices are on the y-axis and the two co-vertices are on the x-axis. Remember guys, this ellipse or that ellipse are centered about or centered at the origin point 0, 0. So this center is 0, 0, and this center is also 0, 0, but not every ellipse is centered at 0, 0. Some ellipses have a different center. Take the center h, k. The standard form for the equation of an ellipse centered at h, k is quite different. It's going to be x minus h all squared over a squared plus y minus k all squared over b squared, everything equals to 1. You can say the center of this ellipse is translated horizontally h units and vertically k units. This negative sign because of the formula, not because the value of h or not because the value of k. So this is the equation. This is the standard form for the equation of an ellipse. It's centered at h and k. We have couple examples today. In example 3, you need to learn how to graph an ellipse described by a given equation. This is the given equation of this ellipse, and we need to graph this ellipse. First of all, you need to write this equation in the standard form. In the standard form, this number in the denominator has to be a squared number, and that number has to be a squared number. Remember guys, in the formula we have this quantity divided by a squared, and this quantity y minus 3 squared is divided by b squared. So if we can write this in the standard form, it enables us to figure out the value of a and the value of b, and this is very important in graphing. So I'm gonna write x plus 4 squared, x plus 4 squared over 49 can be written 7 squared plus y minus 3 squared over 16 can be written 4 squared. Everything equals to 1. And now guys, the main characteristics of this ellipse are the center h comma k. It's very easy to identify, it's very easy to identify the coordinates of this ellipse. The coordinates of this ellipse are -4, yeah, correct, it is not 4, and 3. Remember guys, the formula x minus h. Since this number is positive 4, you can rewrite positive 4 as negative 4. So the x coordinate of the center of this ellipse is -4, and the y coordinate is 3. Two very important information are given to us when we find the value of a and the value of b. The value of a is 7, a equals 7, and b equals 4. Step number 3, you can take this information and create your coordinate plane and start graphing. Start from the center of this ellipse. The center of this ellipse is -4, 3. So -4 on the x-axis and 3. This is exactly the center of that ellipse. Yep. This is the center. The value of a is 7 and the value of b equals 4. A is greater than b. It means this ellipse gonna be a horizontal, the major axis is gonna be horizontal 1. So to figure out the coordinates of the two vertices, you need to take this a and you add it to the -4 one time. So 7 units to the right, horizontal translation 7 units to the right starting from -4. It leads us to stop at 3. Yes, this is the coordinate of that point. So this point is one vertex. The other vertex of the major axis is 7 units to the left from -4. 7 units to the left of -4, it leads us to -11. So at -11, I'm gonna stop and put my second point. So guys, we have the center of this ellipse at -4, 3. We have this vertex 7 plus -4, it's 7 plus -4, it's 3, comma, the y coordinate remains the same 3, and the coordinates of the other vertex in the opposite way, you need to -7 from this -4, it's -11, and the y coordinate remains the same. So now I have the center and I have 2 points, the 2 end points of the major axis. Okay, now we need another 2 points, the co-vertices. The co-vertices are the 2 end points of the minor axis, the vertical one. How do we get that? Starting from the center, we need to do vertical shift 4 units up one time and down another time. If we add this 4 to this 3, it leads us to the point -4 and 7. So -4 and 7 just right here. Yes, this is 1 point, 1 co-vertex. The coordinates are -4, 7, -4, 7. And if you minus, or if you go down 4 units, if you do vertical translation 4 units down, it leads us to the point -4, -1. -4, -1 is just right here. -4, it looks like 40, and -1. So guys, now we have all basic information about this ellipse, so we can start connecting these 4 points around the center of this ellipse. So I will do my best to be accurate. It looks like an ellipse. Actually, it looks like a potato, but let's consider it's an ellipse. This is the center, this is the major axis, and this is the minor axis. This is an approximate image of our ellipse. Example number 4 is an engineering application. In this application, we need to apply the properties of an ellipse you learn in the first 3 examples in order to write equation of a new ellipse. Take a look on that problem. It says a city park in the form of an ellipse with the equation x² over 50 plus y² over 20 equals 1. So this is the equation that describes the park in the shape of an ellipse, measured in meters, is being renovated. The new park will have a length and width double, this is a keyword, double, that the original park. What length and what width? Guys, remember that we have major axis and minor axis of any ellipse. When it says the length and width doubled, it means the major and the minor axis dimensions are doubled. Find the dimension. This is what we need. This is our mission. Find the dimensions of the new park. So our dimension, our job is to find the dimensions of the new park. We need to start with the original one. We need to get the basic characteristics, the value of A, the value of B of the original park. Guys, A², from that given equation, I can figure out that A² equals this quantity 50. Unfortunately, 50 is not a perfect square number, but I can take the square root of both sides in order to figure out the value of A. The value of A gonna be the square root of 50. If you put that in the calculator, you can put it in the simplest form. It's gonna be 5 square root of 2. Similarly, I will do the same to figure out the value of B. B², the quantity underneath y² is B². B² equals 20. If you take the square root of both sides, the value of B equals square root of 20. If you simplify that in the simplest radical form, it gives you 2 square root of 5. This is the value of B, and this is the value of A for the original park. Now we know the dimensions of the original park. We know the distance from the center to the vertex and the distance from the center to the co-vertex of the original park. Now guys, the key word of the new park is the length and the width are doubled. So A dash equals double of this quantity. So 2 times 5 square root of 2. Yeah, the new distance from the center to the vertex of the new park gonna be double this quantity. 2 times 5, it's 10 square root of 2. Similarly, B dash, the distance from the center to the co-vertex is double the distance in the original ellipse. So double this quantity, it's 2 times 2 square root of 5 equals 4 times the square root of 5. This is the new dimensions, the new length, and the new width of the new park. Now our job is to write the equation of the new park. So to write the equation of the new park, it's centered at 0, 0. Apparently it's centered. There is no change. There is no any kind of translation of that center. The original center is at 0, 0. So it remains the same. And the equation is x squared over the square of this quantity, 10 square root of 2 all squared, plus y squared over 4 square root of 5 all squared. Remember the parentheses around everything, and everything equals 1. Or you can simplify this equation and put it in the simplest form. So it's going to be x squared over, if you square this quantity, you need to square the 10, and you need to square the square root of 2, and you multiply them. So it's going to be 100 times 2, it's over 200, plus y squared over the square of 4 times square root of 5. The square of 4 is 16. The square of square root of 5 is going to be 5. So 5 times 16 is going to be 80. Everything equals to 1. This is the equation. This is the equation of the new park after the renovation process. Enjoy this section. Stay safe and keep practicing. See you soon. Bye.